Here's another example, which is where we're going to evaluate a definite integral, the integral from x equals 0 to x equals 4 of x minus 2, that's our function, dx, using right endpoints. What we're doing is taking the problem that we did in the last video and letting the number of rectangles go to infinity, so we get a precise answer for the area under the curve f of x equals x minus 2. Okay, let's go through this one. This is a happy face. We're going to use note number 103. That says the integral, the definite integral from x equals a to b of f of x dx is equal to the limit as the number of rectangles goes to infinity of the Riemann sum, the sum I equal 1 to n of f of x sub I times delta x. All right. So this is very similar to our last video. In our last video, we used 6 rectangles to get a really rough estimation of the area under the curve. That estimation at Riemann sum was r sub 6 because we had n equal to 6. There we used n equal to 6 subintervals, but here we're going to use infinitely many. Here we'll use infinitely many subintervals n. That's what happens when you let the limit of n, the number of rectangles, go to infinity. When we do this, it will give us very accurate results of the, quote, estimation of the area under this curve. Okay, so that's where we're headed. We're going to get a numerical solution. We're going to evaluate this integral. So, use f of x equals x minus 2. That's given to us. The integral from x equals a to b equals the integral from 0 to 4 implies that our restriction on the domain a to b is 0 to 4. Step 1. Find the n expression for the width delta x. Now this time we don't have a value for n, so n will be in our final expression for delta x, the width delta x. We use the same formula, delta x equals the endpoint b minus the initial point a divided by n. But we don't have a value for n here, so delta x equals 4 minus 0 over n. It equals 4 over n. Step 2. Find an expression containing a and or I for the sample points. In this case, our sample points are going to be right endpoints. Okay, sample points, right, no, not left, right endpoints. Okay, the formula for sample points when you're using right endpoints is x sub I equals x sub I minus 1 plus the width delta x. Okay, let's see a pattern here. X sub I. Well, x sub 0 is equal to a. That's our first point, our first x value. That's 0. X sub 1 is 0 plus the delta x that we calculated in the previous step, 4 over n. So that's equal to 4 over n. Let's write that out in terms of an index I. That's 4 times 1 over n because the index was 1. Okay, then the next one is x sub 2 equals the previous x value, which was 4 over n, plus the delta x, which is 4 over n, gives us 8 over n. And if we wanted to write that in terms of the index I, that'd be 4 times 2 over n. Then x sub 3, oh, we're still working on that there. Okay, it's 4 times 3 over n, or 12 over n. And then we can get a general statement of x sub I. X sub I, the ith x value, is equal to 4 times I over n. Now, let me write that down, 4 times I over n, and then I'm going to stop this animation to say something. The fact of the matter is that we do have a formula that would have given us the answer to step 2 without going through all this iteration, and that is from note 101. In step 2 here, for note, we could have used note 101 formula, x sub I equals x sub O plus I times delta x, and we could have just used that form of x sub I from note 109b, I'm sorry, from note 101, and then that would have given us x sub I equals the initial x value 0 plus I times delta x, which is 4 over n, so it would have given us 4I over n. I'm going to make that comment after this video, but I should probably redo the whole video and just say, hey, we didn't have to go through all this. We could have just used this formula that you're going to see in the comment after this video. Let us continue. Number 3, Find the definite integral. Okay, now we're going to use note number 103. The definition of the definite integral is a limit of the Riemann sum. The integral, from note 103, the integral x equals 0 to 4 of f of x dx is equal to the limit, as n approaches infinity, the number of rectangles, of the sum of I equal 1 to n of f of x sub I times delta x. Okay, let's use that. Thus, here we have the integral from x equals 0 to 4, f of x dx equals a limit of the sum of f of xi times delta x. Okay, now replace x sub I with the general statement 4I over n. That's what we saw in step 2. It's 4I over n right there. And then replace delta x with what we got in step 1. It's 4 over n. All right. Now, 4 over n does not depend on I, so we can bring it out in front of the sum, but not in front of the limit, because it does depend on n. So this is a limit over n of f over n times the sum over I of 4I over n minus 2. Where did that come from? Wait a minute. That's true because the function was defined as f of x equals x minus 2. We just evaluated it. So that's a limit 4 over n times the sum of 4n times I minus the sum of 2. What did we do there? Well, here we use the summation rule number 3 that we saw in note 109. Now we take the limit of 4 over n times the sum of 4n times the sum of I minus the sum of 2. Okay, how did we do that? That was just pulling the constant outside of the summation. Now we're going to bring the 4 over n back in the next video.